Good evening, everybody. Hope all of you all are ready so that we can work today's work. Okay, this is the second day. This is the second day of our program, and week one, day one was completed yesterday. We finished the first part of the MCQ 2020. Okay, 2020. I'm audible, no? Okay, right. So day one, 20 MCQs, one structured essay, one essay. Day two also, we'll be having 20 MCQs, one structured, one essay. We'll start work today because a lot of work to do. Okay, we'll start today's work. Okay, right. Okay, have a look. So this is actually MCQ number 21. Nah? Actually MCQ number 21. But for today's paper, MCQ number 1. Right. Have a look. Consider the following statements regarding the viscous flow of a fluid. Viscous flow of a fluid. Right. Viscous flow. Now, when it comes to viscous flow, we have to consider Poisson's equation. Here, Poisson's equation. You can't consider normal fluid flow equations. Okay, you can't consider normal fluid flow equation. Right. Have a look. Here, Poisson's equation is volume flow rate that is equal to pi over 8 eta r to the power 4 delta P over delta L, pressure gradient. This is called Poisson's equation. What equation? Poisson's equation. So why can't you use conventional equations? Why can't you use Bernoulli's equation? You can't use them because here it is a viscous liquid. When there is a viscous liquid, you must use Poisson's equation. Okay, right. So speed of flow is maximum along the axis of the tube. Now, if you draw fluid flow, remember no slip condition comes into play. No slip condition comes into play. That means the boundary is at rest, so fluid particle is also at rest. Boundary is at rest, fluid particle is also at rest, right? So from rest, gradually the velocity will increase. Velocity is maximum at the axis, velocity reducer. So if you draw the profile, it's going to be a parabolic curve like this. Parabolic curve like this. Maximum velocity will occur at the axis. Maximum velocity will occur at the axis. So what can you say? Speed of flow is maximum along the axis of the tube. Statement A is correct. Statement A is correct. Right. Quickly you can draw that. Huh? Draw with me. Quickly you can draw that. Right. Now look. Second statement. Rate of flow of liquid is proportional to the internal cross-sectional area. Now I know some of you all are very tempted to look at this and say, sir, area pi r squared. No. Poisson's equation tells you volume flow rate is proportional to 4th power of internal radius and pressure gradient. So you can't say area. This pi is coming not because of the area, because the proportionality constant is pi divided by 8. Proportionality constant is pi divided by 8. So it is not coming because of the area. So you can't take area. So volume flow rate is directly proportional to 4th power of the radius. So you can't say proportional to internal cross section is a wrong statement. You can't take B. You can't take B. Right there. In the relationship, pi is coming. In the relationship, pi is coming due to the proportionality constant. Due to the proportionality constant. Due to the proportionality constant. Therefore, we cannot consider it to depend on the cross-sectional area. We cannot consider it to depend on the cross-sectional area. Right. Part C. Rate of flow does not depend on the temperature of the liquid. Wrong. Remember eta. Coefficient of viscosity depends on the temperature. Now, if you draw temperature eta graph, what will happen is with temperature increases, coefficient of viscosity will reduce. So, rate of flow does not depend on temperature. No, depends on temperature. When temperature is changing, eta will change. When eta changes, volume flow rate will change. What is eta? Eta is called coefficient of viscosity. Coefficient of viscosity. Clear, no? So coefficient of viscosity depends on temperature. Therefore, volume flow rate will also depend on temperature. Right there. The coefficient of viscosity depends on temperature. The coefficient of viscosity depends on the temperature. The coefficient of viscosity depends on the temperature. Therefore, the volume flow rate will also depend on the temperature. Therefore, the volume flow rate will also depend on the temperature. Right, no? So from this you can select what is your correct answer. C is also wrong. Only A is correct. Only A is correct. Yeah. Only A is correct. Okay. Right. Moving onwards. Okay. Read. Which of the following energy displacement graph best fits the variation of kinetic energy? Please underline, even in your paper when you are doing in the exam, you underline the keywords because the letters and all seem the same. So underline it and you redefine. Okay? Kinetic energy, potential energy, total energy. So this is normally you learned in your simple harmonic motion lesson. Total energy will never be the same. I mean, will be always constant. The total energy normally half m omega squared a squared. If you take potential energy, half m omega squared x squared. If you take kinetic energy, half m omega squared a squared minus x squared. A squared minus x squared. So these are your variations. You can see total energy will remain constant. Potential energy is maximum at the extreme points. When x is maximum, potential is maximum. So you can see easily x is maximum, potential is maximum here. Also, maximum kinetic energy occurs when x is equal to 0. So which gives us correct answer is answer number 2. Correct answer is answer number 2. The total energy is half m omega squared a squared. Potential energy is half m omega squared x squared. Kinetic energy is half m omega squared a squared minus x squared. From there, you can easily find your answer. Okay, no? Right. I'm sure all of you all would have got that correct. Okay. Carefully look. One limb of glass of U-tube is made from a capillary. Now remember, when the word capillary comes, normally surface tension will come into play. Right? In a capillary tube, surface tension will come into play. When water is poured into the U-tube, the equilibrium heights of water columns inside capillary and wider tubes. Remember, the word wider means there is no surface tension effect there, or minimum surface tension effect. Capillary tube guaranteed there will be surface tension effect. So this will have a surface tension effect. That will not have a surface tension effect. Right. As measured from the OO level are simple H and capital H respectively. So this height will be simple H heights. That height will be capital H heights. Right. The variation of simple H with capital H is best represented by Okay, look at the board carefully now. What I'll do is, I think I will redraw this for you. Observe. Now, here there is a very thin capillary tube. Here there is a thicker height. So when you pour water, now they ask from this level, nah? O dash level they ask. Even if you pour a little amount of water, all of you all know by practice, here the height is large. Here the height will be less. Okay, no? Height will be less. So here the height of the capillary is simple h. Here the height of the wider tube, so less surface tension effect, capital H. Right. Remember here, when there is a meniscus, if I mark it, here you have atmospheric pressure. Just below it, the pressure will be slightly different. Then we can find the pressure at B, here pressure at C. Here, of course, atmospheric pressure is acting. Okay. Remember, wider tubes, there is less effect taking place. Wider tubes, there is less effect taking place. Thinner tubes, there will be capillary effect taking place. Right. Now look at this carefully. Observe this carefully. Right. When you are writing this, let's say the radius is simple. We can easily say, now this you will learn under surface tension, PATM minus pressure at A, pressure difference is 2T divided by simple R. Simple R is the radius of the bubble, but we say angle of contact is 0. So what happens is, radius of bubble and radius of tube both are same. From this we can find the pressure at A, PATM minus 2T divided by R. Pressure at A can be found. Normally this is a very simple thing you learn in surface tension. It's a very simple thing. Pressure at A plus H will give you pressure at B. So here, pressure at A plus simple H rho G will give you pressure at B. So if I do the substitution here for pressure at A is PATM minus 2T over simple R plus H rho G is equal to pressure at B. Now what is pressure at B? You can see pressure at B is equal to pressure at C. Pressure at B is equal to pressure at C. So what is pressure at B? PATM minus 2T over R plus H rho G. Pressure at C is equal to PATM plus capital H rho G. You can now cancel off terms which are not important. PATM cancel off. If you look at this, they are asking the variation. Simple H y-axis, capital H x-axis. Right. Simple H y-axis, capital H x-axis. Right. Good. Okay. Look at this. I'll take this to the other side. Look at the board now. So here, simple H rho G is equal to capital H rho G plus 2T over simple R. Divide everything by rho G. Simple H is equal to capital H plus 2T R rho G. Please look at this. This graph is of the form y is equal to x plus c. Y is equal to x plus c. There you go. If you want, you can take the photo. These are the workings. Right? Once you get this, then directly from here you can go. What is y is equal to mx plus c? Only one answer. Answer number 1. Here. Only one answer. Answer number 1. Okay, now? There you go. So, a little bit of surface tension knowledge here as well. little bit of surface tension knowledge as well. So here surface tension knowledge is there. So what's happening is when you pour a little bit of liquid, here it rises more. Capillary tube rises more. This is a capillary tube. Capillary tube. This is a wider tube. What do you call that? A wider tube. Wider means no surface tension effect. Meniscus is straight. From here, you can build the relationship and get your answer. Okay? Right. Okay. Moving on. Moving on forward. Carefully look. A uniformly charged large metal plate is kept at zero potential. Now, yesterday we have done this. Uniformly charged means there will be a electric field acting. Electric field acting. The electric field is equal to sigma divided by epsilon naught. Electric field is independent of the distance. Okay. They are telling you here potential is 0 volt, here -1. These are electric field lines. So you know electric field is negative potential gradient. Negative potential gradient. Right. Now your electric field here, wherever you take will be the same. What do you mean by negative potential gradient? Final minus initial. Field lines are going final minus initial. So -1 minus 0 divided by 1 centimeter. To simplify this, minus minus plus 1 volt per centimeter. Right. What are they asking you? They are asking the equipotential surface 2 centimeters away. 2 centimeters away means what? Somewhere here. 2 centimeters away. So from 2 centimeters. So we can apply the same theorem. What's the same theorem? Very simple. Same theorem you can apply. Now you know electric field strength equals negative potential gradient. Negative potential gradient. Electric field strength is negative potential gradient. Electric field strength is 1 volt per centimeter. Final minus initial. Final, we don't know the voltage, no. Final voltage, we don't know, V2. V2 minus initial 0 divided by 2 centimeter. Cross multiply, 2 minus comes, V2 is equal to minus 2 volt. Done. So your answer there is going to be minus 2 volt. Right? Write this down. Write this down. For a uniformly charged metal sheet, the electric field strength is independent of the distance from the plate. The electric field strength is independent of the distance from the plate. Electric field strength is independent of the distance from the plate. Also, we know that the electric field strength is equal to the negative potential gradient. Is equal to the negative potential gradient. Is equal to the negative potential gradient. Therefore, we can find the potential. Therefore, we can find the potential. Therefore, we can find the potential. So, basic work, quickly write it down. Right. Okay, no? Okay. Right. Moving on. MCQ number 5. Read. Cross-sectional view of a variable capacitor. Variable capacitor. With parallel plates are shown in the figure. The separation between adjacent plates, that means each of these separations have a particular distance. Right. Area of the plates are given. Distance is given. Epsilon naught is given. What's the capacitance? Right. When you have something like this, very simple. Some people like to put plus and minus. I'll also put plus and minus, easy enough for all. I'll also put plus and minus, right? We'll take this as the plus, we'll take this as the minus. Plus means all the plates are plus. So here also plus, here also plus. Here also plus, here also plus. Here also plus, here also plus. You know? If you take minus, these are all minus plates. Here also minus, here also minus. Here also minus. I'll use a different color maybe. Something that is prominent, like this. Is it prominent? I don't know. Maybe it's not prominent, I don't know. And minus, 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 minus. If there is a electric field, it will be between plus and minus. So plus and minus, there is electric field, there is a capacitor. Plus and minus, there is electric field, there is a capacitor. There is a capacitor, there is a capacitor, there is a capacitor, there is a capacitor. Now you might say, sir, outside also negative is there. Outside negative has no meaning. There's no plus. So we can ignore the outside negatives. We can ignore the outside negative. Okay, no? So you put the plus and minus and go. You can ignore the outside negatives. Ignore the outside negative. Yeah. Ignore the outside negative. Right. Now what? Very simple. How many positive plates are there? 1, 2. How many positives? 1, 2, 3, 4, 5, 6. 6 positive plates. 6 positive plates. How many negative plates are there? How many negative plates are there? Negative plates. 1, 2, 3, 4, 5, 6. 6 negative plates. 1, 2, 3, 4, 5, 6. What is this? Capacitors in parallel. Capacitors in parallel. I'm sure electric fields are done by now. Capacitors in parallel are like resistors in series. 6 times. One capacitor we know A epsilon naught over D. 6 A epsilon naught divided by D. So here 6A 5 centimeter squared convert to meter squared. Epsilon naught 9 10 to the power minus 12 divided by distance. Distance is 0.5 centimeter. There you go, minus 2. Okay, now? Right. So 30 into 9, 270. 270 times 2, 5,400. So you have 5,400 here. 5,400. Here, to the power minus 3, minus 7. Minus 7. So 9 here, sorry. Minus 4, minus 12, minus 4, minus 12, minus 16. Minus 16, positive 2 is going to be minus 40. What are the answers? They are given in pico. Pico. Pico means 10 to the power minus 12. Minus 12. So here if you simplify this, so 0.5 centimeter, centimeter convert to meter, 0.5 centimeter squared, 10 to the power minus 4, right? 9 10 to the power minus 12, that's also okay. A epsilon naught divided by D, right? Done. So if you simplify this, 6 times 5, 30, 30 times 9, 270, I'm sorry. 270 means 540 here, 540 here, right? One additional 0 has come, right? Okay. Now 2 decimal places, you jump. 2 decimal places means 5.4 10 to the power minus 12 farad. Minus 12 is called pico. That's from your units and dimensions knowledge. 5.4 picofarad. 5.4 picofarad, answer number 5. 5.4 picofarad, answer number 5. So write there small sentence. We can consider one plate as the positive terminal and the other plate as the negative terminal. And the other plate as the negative terminal. From this, we can show that it's a combination of capacitors in parallel. From this, we can show that it is a combination of capacitors in parallel. It's a combination of capacitors in parallel. Therefore, capacitors in parallel are like resistors in series. Capacitors in parallel are like resistors in series. Okay, now? Quickly write down the ones who need it. I'll give you, I don't know, 10, 20 seconds. Okay, right now. Right, we move on. We move on. MCQ number 6. MCQ number 6. Right. Now, even though this looks like a difficult question, it is not a difficult question. Very simple. Right. All components shown in the circuit are ideal. When they say ideal, remember, ammeters have zero resistance. Voltmeters have infinite resistance. That means voltmeters, across ideal voltmeter, no current passes through. No current passes. Ideal voltmeter, no current passes through. Then ideal ammeter. Ideal ammeter, there is no potential difference or no potential drop. No potential drop. Right. Short form I write PD. Yeah? Short form I write PD. Okay. Right. Now look at this carefully. They are telling you center zero voltmeter is used to measure the voltages at A and B. Where is A? A is here. B is here. Right. Corresponding readings will be how much? Now, before you do this, don't be in a hurry. First, you apply Kirchhoff law. You apply Kirchhoff law. If you apply Kirchhoff law, sum of EMFs equals sum of potential differences. Sum of potential differences, you can also say sum of IRs. Easy, no? Potential difference means IR. So, when the loop travels minus to plus, you can add plus 5. Current is traveling now in that direction. Current is traveling in that direction. Loop direction, current direction same. Loop direction, current direction same. So you can potential differences are positive. I times 10 plus I times 50 plus I times 20 plus I times 10. Some people apply V equal IR for this. That is not A level. I'm doing this so that even if there's a essay question, you can handle it. Huh? Some people put V equal IR for the whole circuit. You can't put V equal IR and learn electricity. In your level, you should know Kirchhoff law. Okay. So you're applying the rules here. Consider loop minus to plus positive. Loop direction, current direction, same positive. 10 is equal to. Common term is I. Take I out. 10, 20, 70, 70, 20, 90, 90, 100. From this, current is equal to 10 divided by 100, 0.1 ampere. Some people say V equal IR, we get the same answer. Wrong. V equal IR is potential difference between 2 points. You can't apply for a circuit. Yeah, you can't apply for a circuit. Wrong theory. So be careful. Always apply Kirchhoff law. Right. Now, current is traveling from here to here. Current travels from high potential to low potential. You should know that. So across this, I'll highlight. Right. Across this, I apply delta V equals IR. Some people apply V equal IR also wrong. It's Ohm's law, delta V equal IR, potential difference. You might say, sir, in my O-level science book, it's there, no, V equal IR. No, it should be delta V equal IR. Delta V is changed. Higher minus lower. Lower has been grounded. Grounded means what? Zero, like I'm showing here. Now, high to low. Potential at A minus high to low. Potential at X is zero, grounded. Here grounded. Can you see? Potential difference. What is the current passing through? Current passing through is 0.1, 0.1, 0.1. I don't know whether I can write there, but I'll write and see. Times resistance. Resistance 50. So what is the potential at A? Potential at A is zero point 0.1 times 55 volt. 5 volt here. Now apply here. Potential difference equal IR. Current is traveling from high potential to low potential. High potential 0. Current is going down. High potential minus low potential VB. Current is 0.1 into what's the resistance there? 20. So VB is equal to minus 2 volt. High potential 5 volt, low potential minus 2. 5 volt minus 2 means answer number 2. Understood? One reason I'm doing this is you learn the correct way. Don't learn it the wrong way. Yeah. My objective is to make sure whoever teacher you study, that's no problem. There is no issue. But you learn it the correct way. The correct way will always get the logic correct for you. So here 5 volt is there, here minus 2. You can nicely find your answer. Remember, don't apply V equal IR for circuits. For potential differences, yes, between 2 points. Full circuit, if you are applying, please apply Kirchhoff law. Some people, for the easiest, sometimes they don't know Kirchhoff law, so they teach like this. Don't get caught to that. Make sure you get the correct thing. Yeah, get the correct thing. Okay, right. Right now, right. Next one. I think yesterday was the essay question. I think the essay question will help you do this very easy. Moment of inertia of a flywheel is 9 kilogram meter squared. Flywheel from rest to 600 RPM. Find the work done on the flywheel. So here omega naught is 0. Omega is equal to 2 pi n. N is 600 revolutions per minute. 600 revolutions per minute. 600 divided by 60 is 10. 10 times 2 pi is 20 pi. 20 pi radians per second. That's your omega. 20 pi radians per second. Now apply work energy principle. Work energy principle is work done by external forces or external torques equal increase in rotational kinetic energy, increase in rotational kinetic energy plus work done by resistive torques. Work done by resistive torques. Increase in rotational kinetic energy is final rotational kinetic energy half I omega squared. Don't forget. 20 pi squared minus initial, no resistive work done. Be careful now. 20 squared is 400. 400 times 9 is how much? 3600. 3600 divided by 2 is 1800 pi squared joules. 1800 pi square joules. Answer number 2. Answer number 2. So I'm sure you have done that. If you looked in yesterday's work, this experience is already there. Can you see? One question's essays experience, there's MCQ also. So that's what I'm telling. If you learn it correctly, if you follow this program correctly, guaranteed whatever level you are, your level will go up. Guaranteed. Whatever level you are, your level will for sure go up maximum. You just need to be disciplined and honest to yourself. Guaranteed your level will increase. Right. Okay. Now, displacement of a particle measured along the x-axis with time is shown in the figure. Magnitude of the velocity is largest when it travels. Now, what kind of graph do you have? You have a displacement time graph. Displacement time graph. Gradient gives you velocity. Gradient gives you what? Velocity. Gradient gives you velocity. Right. Now you must select. What is the question? The question is, which object has the largest magnitude? Largest magnitude means largest gradient. Please look at this and tell me which has the largest gradient, largest slope. Looking at this, I can say this slope is bigger. BC, no? BC, no? So B to C has the largest slope. B to C has the largest slope. Okay. Very easily you can get B to C. Okay, right. Look at this carefully. Now remember, so however small the question, however easy the question, see, I'm making notes. These notes you should collect. Take a CR book, paper, number, note. Make sure you write it. Wherever you are in Sri Lanka, please do it. Your marks will guaranteed increase. Today, if you are getting 10 marks, guaranteed next exam the marks will increase. Keep following this, the marks will increase. My objective is, even if you are the weakest, you must pass this exam. There is no child in my vocabulary who is the weak. In my book, nobody is weak. Everybody has different levels of discipline, different levels of commitment. I want you to be committed for this. Whatever level you are, you will go up. Whatever notes I make, take a CR book, write. Take a small paper, write it. You know that next time when you see something like this, exactly the short point to apply. Okay, right. Enough talking, let's keep going. Right. Look at this. An ideal gas is taken from state A to state B. Now, these are thermodynamics section. I'm sure you have done thermodynamics in your thermal class, thermal physics lesson. State A to state B separately, there are three different paths. Three different paths. If UB is greater than UA, what do you mean by UB? UB means symbol for internal energy. Now, these are the notes. Internal energy is 3 over 2 RT. If there are N moles, nRT. Internal energy depends on the temperature, absolute temperature. Now they are telling you UB is larger than UA. That means temperature at B is larger than temperature at A. Temperature at B is larger than temperature at A. Right. Keep that in your head. Okay. Now look, work done by the gas is same for all three processes. Right. First note. Work done is the area under the graph. Work done equals area under PV graph. Area under PV graph. Now tell me, wherever you are in Sri Lanka, are the areas under these graphs same? I'll color it to you. Finish now. I'm going to color it. Graph number 3. Green color. That's the area. Graph number 2. Red color. This is the area. Graph number 1. Graph number 1. This is the area. How can I color one? Opposite way. Tell me. Are the areas same? No. Areas are different. Actually, work done in 1 is greater than work done in 2 is greater than work done in 3. Work done are different. Statement A is wrong. That means wherever there is A is wrong. A is wrong. A is wrong. Method of elimination. If A is wrong, whatever the answers it A is wrong. Method of elimination. You know, see, things are easy, not difficult. Things are easy. Next, heat is absorbed when gas is taken along path 1, whereas heat is liberated when gas goes from to path 3. Right. Now look at this. For this, I will move this up a bit. Huh? Okay. Workings are here. Right. Look. Delta Q equals delta U plus delta W. This is called first law of thermodynamics. What law? First law of thermodynamics. Right. Now in your thermal physics lesson, nicely they would have taught you how the first law comes. How the first law comes. This delta U is always now path number 1, path number 2, path number 3. Delta U depends on initial point and the final point. Now look at this below. So look at this. Initial point and final point all are same. That means your delta U is UB minus UA. Why? Whatever the process, final and initial don't change. So UB minus UA. UB minus UA. Right. Look at this carefully. UB minus UA. Fixed. So if I go, whatever path, if I go, internal energy change, delta U is UB minus UA, fixed. These are fixed value. So what is your delta Q depending on? Delta Q is depending on delta W. Right. Now look at this. Here expansion. Volume is increasing. Here volume is increasing. Second one was expansion. Volume is increasing. Third one was expansion. Volume is increasing. Volume is increasing means work is pushing out. Increasing means imagine a piston cylinder. If the volume increases, if the volume increases, piston cylinder, piston cylinder, right. Piston cylinder, initial piston location is here. Now final piston goes here. What has happened? Volume has increased. Somebody is pushing this out, no? Somebody is pushing this out. That is work output. Remember, according to sign convention, work output is positive. All these three processes, there is a work output. Work output means, here you go, work is positive. So here, work is positive. Work is positive. Here, work is positive. If work is positive, these fixed, no? This is also positive. Why? UB larger than UA is given. These is also positive. Positive means delta Q is also positive. What do you mean by delta Q positive? Delta Q positive means heat input. Heat input is positive. So all the three processors work is positive. All the three processors delta U is positive. Therefore, all the three processors delta Q is also positive. Delta Q means heat input. Right. Now let's go back. Where heat is absorbed along path 1. Absorb means taken in. Yes, correct. While heat is liberated along path 3, given out. Wrong. No? All three it's taking in. Statement B is wrong. Statement B is wrong. B is wrong. Wherever there is B wrong, your only obvious answer is answer C. But let's see why. Temperature at B is higher than A. We have found that. Temperature at B is higher than A. That means C correct means only C is correct. Okay, no? Right there. Internal energy depends on the absolute temperature. Internal energy depends on the absolute temperature. Internal energy depends on the absolute temperature. If the volume increases, there is a work output. If the volume increases, there is a work output, which is positive. And if the volume reduces, there is a work input. There is a work input, which is negative. Which is negative. We can observe in all the three processes there is a work output. We can observe in all the three processes there is a work output. We can observe in all the three processes there is a work output. There is a work output. And the internal energy change is also positive. And the internal energy change is also positive. And the internal energy change is also positive. Therefore, heat transfer will also be positive. Heat transfer will also be positive. Heat transfer will also be positive. This means all the three processes there is a heat input. All the three processes there is a heat input. Okay, no? All the three processes there is a heat input. Right. Moving on. At atmospheric pressure, the specific latent heat of ice and vaporization is 20 10 to the power 5. I think this is 10 to the power 5. 10 to the power 5. Right. Specific heat capacity of water is 4000. Minimum amount of heat required to convert 1 kilogram of ice. Now, how do you convert ice? You supply heat. 0 degree ice converts to 0 degree water. 0 degree water converts to 100 degree water. 100 degree water converts to 100 degree steam. That's your conversion. Here it's going to be MLF fusion. Here MS or MC delta theta. Here MLV. So amount of heat transferred Q is equal to MLF. Mass is given 1 kilogram, 3 10 to the power 5. MC delta theta. 1 times 4000 times change in temperature delta theta is 100 plus. Mass here is 1 kilogram. LV is equal to 20 10 to the power 5. Add everything. 10 to the power 5. 4, 3, 7. 7 and 20, 27. 27 10 to the power 5 joules. Do you have an answer like that? Yes. Answer number 1. Answer number 1. Right now? Very simple work done. 0 degree ice to 100 degree steam. Okay. 0 degree ice to 100 degree steam. Right. Okay. Dew cannot appear if dew. Whenever you learn, now by now you must have learned humidity. When you learn humidity, you learn two curves very importantly. Temperature absolute humidity curve, relative humidity temperature curve. Relative humidity temperature curve. So in this curve, keeping these curves only, you can come to these conclusions. Right. From high temperature, if you reduce, H will not change. But after you reach dew point, absolute humidity will reduce. Dew point is the temperature at which existing mass of water vapor saturates. If you take RH up to the dew point, if you reduce, RH will increase at 100, at the dew point onwards, RH is 100%. Relative humidity is 100%. Right. Read now. dew cannot appear if temperature is high, relative humidity is 100%. Wrong. RH is 100% means dew point has been reached. Whether it's high or low, we don't know how much the dew point is. But if RH is 100%, guaranteed has reached. Temperature is low, absolute humidity is equal to the corresponding value at dew point. Absolute value is equal to the corresponding point at dew point means RH is 100%. RH is 100% means dew has been reached. Second one is also wrong. Whether temperature is low or high does not bother, but there's a point. At that point only that matters. So absolute humidity is equal to the corresponding point at the dew point means this point means RH is 100. That means dew has formed. Right. Temperature is high. Don't worry. You don't know what this value is. Right. Absolute humidity is equal to the corresponding value at dew point. So temperature low or high, we don't really care. Dew will guaranteed form. Dew cannot appear. Dew will appear. All these cases, dew is appearing. Remember, in the future MCQ, they might ask the opposite of this. When dew can appear. So here you go. Temperature is below the dew point. Relative humidity is 100%. Right? Temperature is below dew point. Relative humidity is 100%. Correct? Saturation will take place from the curve. Temperature is low. Absolute humidity is less than the maximum possible. Less than the maximum possible at that particular temperature. Look very carefully. Absolute humidity is less than the maximum possible. What is the maximum possible? Maximum is mass of water vapor required to saturate. Right. Temperature is low temperature. Absolute humidity is less than the maximum possible value. Absolute humidity is maximum here. If you have less than the maximum possible value, can dew form? Dew cannot form. Maximum possible value is mass of water vapor required to saturate. Maximum possible. You are having less than that. If you are having less than that, saturation cannot take place. Only 5 is correct. Right there. Dew will occur only when the existing mass of water vapor, only if the existing mass of water vapor saturates. Only if the existing mass of water vapor saturates. If the existing mass of water vapor per volume, if the existing mass of water vapor per volume is less than the maximum, saturation can never take place. So dew cannot form. Saturation can never take place. Therefore, dew cannot form. Okay, no? Perfect. Right. It's a very simple, interesting section. It's a very in-depth, very practical, very important for your life. These two curves, don't forget. Okay. Saturation or dew will occur. Now, early morning when you go and walk on the grass, there is water. Huh? Why? That means in the environment, whatever water vapor is there has saturated, causing the formation of dew. Some days when you go out, the grass is not wet. That means that temperature, saturation has not taken place. Okay, no? Right. Okay, keep moving. A transverse pulse is traveling along a stretched string. The left end of the string is tied to a light ring. When they say light ring, remember always smooth reflection. When they say light ring, always smooth reflection. Smooth reflection. Smooth reflection means number one, no phase change. No phase change. You must have learnt in your theory. No phase change means whatever comes first will go out first. Same time. Whatever comes second will go out second. Correct answer is answer number 2. Remember, smooth reflection, no phase change. No phase change. So whenever there is a light ring, remember smooth reflection occurs. Smooth reflection occurs means there is no phase change. There is no phase change. Right? Okay, no? Moving on. Moving on. Right. A geostationary satellite. By now you are done, no? Gravitational fields. Geostationary satellite. What is a geostationary satellite? With respect to Earth, the satellite is at rest. That's the way you must write in your exam. Huh? With respect to a particular position, if a satellite is at rest, we say geostationary. Don't write satellites periodic time equals Earth periodic time. Geostationary satellites can be placed on any planet, not only on Earth. So with respect to a particular point, if a satellite seems to be at rest, it is a geostationary satellite. The periodic time of the satellite and the periodic time of that planet both are same. That's a different story. Right. A geostationary satellite moves in orbit at radius RA. Another geostationary satellite. Geostationary satellites have one periodic time. You know Kepler's law. P squared is proportional to R cubed. Kepler's law. Kepler's law. I'm sure you have learned this. If the orbit periodic time is the same, the orbit radius is also same. You can't have two radiuses. So technically, RA equals RB. RA equals RB. That's it. Right there. A geostationary satellite has a single periodic time. Has a single periodic time. According to Kepler's law, there should only be one orbit radius for a geostationary satellite. There should be only one orbit radius for a geostationary satellite. Okay. Right. Moving forwards. Right. Current flows in a closed loop as shown in the figure. This you will learn under Biot-Savart theorem, magnetic field. Now, before you learn this, due to a circuit at the center, there will be a magnetic field. You can take your right hand rule, curve the four fingers of the right hand in the direction of the current. Thumb will give you magnetic field, in this case going inside. If the current is going in the opposite direction, current going anti-clockwise, field lines are coming out. Field is coming out, I'll mark with a dot. Field is coming out, field is going in, right. Now, if you take these slicers, you can symmetrically see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here, one angle. Here the other one. Here the other one. Here the other one. Here the other one. 1, 2, 3, 4, 5, 6. If you take a pizza and cut it into 6 equal angles, each angle will be how much? 360 divided by 6, 60. How many small ones you have? 60, 60, 60, 180. How many big ones you have? 60, 60, 60, 180. That means you have big slicers 180 degrees, small slicers 180 degrees. Right. Current is going clockwise, so big slices 180 degrees, radius is R2, plus small slices 180 degrees, radius is R1. Current is going in the same direction, anti-clockwise. Full circle, magnetic field at the center is mu naught I divided by 2R, 2 times the radius. Half a circle means mu naught I divided by 2 times R2 full circle into half. Here clockwise current means field is inverse, plus. Here current is I, again field is inverse. Mu naught I divided by 2R1 is the full circle. Here you have half a circle, and that is also inverse. So what is your resultant magnetic field? Resultant magnetic field, you can see now, both are in the same direction. Both are in the same direction means vector addition. Mu naught I divided by 4R2 plus mu naught I divided by 4R1. Mu naught I divided by 4, 1 over R1 plus 1 over R2. Looking at this, you will see answers are not there. Now the marking scheme also has told, marking scheme has no answer. So this is your correct answer. Mu naught I divided by 1 over R1 plus 1 over R2. 1 over R1 plus 1 over R2. Magnetic field is acting inverse. So this, I think, no answer. Here all is given. All is given. Okay. Even though they have given all, we should know how to get the answer. Okay. We should know how to get the answer. Right. Okay, no? Right. Nice question. Optics. Consider the following statements regarding astrotelescope and compound microscope. To obtain higher magnifications, the telescope must have objective lens of long focal length and eyepiece of short focal length. Yes, no? Angular magnification for the astronomical telescope, normal adjustment, f0 divided by fe. By now, you should remember these. Huh? Magnification, astronomical telescope, alternate adjustment, f0 over fe divided by fe over d plus 1. You should know this. So anyway, telescope has a larger f, so f increases, smaller fe, this further increases. Statement A correct. Statement A correct. This is for astronomical telescope, right? To obtain higher magnification, the microscope must have objective of shorter focal length and eyepiece of longer focal length. This is wrong. Reason, magnification, compound microscope, normal adjustment. I'm sure by now you should know. V0 over F0 minus 1, 1 plus D over Fe. Here, compound microscope, alternate adjustment, you should know. V0 over F0 minus 1, D over Fe. This should be there. To obtain higher magnification, remember this also should reduce, this also should reduce. Then only this value increases. Then only this value increases. This should also reduce, this should also reduce. Both should have small, so B is correct. Wrong. At normal adjustment, the separation of the telescope is equal to the sum. Correct. Normal adjustment length of the telescope is F0 plus Fe. So C is correct. A and C is correct. A and C is correct means answer number 4. A and C is correct means answer number 4. Right. Let's write this down. To obtain higher magnifications for a compound microscope, the the focal lengths of both the objective and the eyepiece should reduce. The focal lengths of both the objective and the eyepiece will reduce. The focal length of both the objective and the eyepiece will reduce. Must reduce. As indicated in the following equation. As indicated in the following equation. Okay. Write down. These are the notes you should have. A-level MCQ comes quickly, tak, 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 you should write this. Then you know what to do. Right. Okay, no? Moving on. Right. A radioactive element. Where did you learn radioactive yesterday? GM tube. Geiger-Muller tube. Yeah? Radioactive element. These are element XA86. XA86. Decays to a stable atom, right? No? Radioactive nuclei emit energy and particles to become stable. By several alpha emissions, alpha means photo emissions, becomes a stable Y 20682. Now 86 has become 82. 4 has reduced. That means two things like this. 2 alpha means here bottom will be 4. 86, 4 goes, 82 is there, right? Then here it's 8. 4 times 2, 8. 206 plus 8 is going to be how much? 240. 214. Answer number 5. Chemical balance equations, I think in basic chemistry or learn. Maybe if there's an IT student joining here, you have a small problem. But remember, not difficult at all. Alpha is just helium nuclei 42. This is 86. Left hand side mass and right hand side mass should be same. Right hand side 82. 2 times 2 is 4. 82 plus 4 is 86. Correct? 206. 4 times 2 is 8. 206 plus 8. How much? 240. Basic, what do you call, chemical balance equation. Right? Okay, no? Right. A light beam is incident on photosensitive surface. Photosensitive means you learn this under photoelectric effect. Photoelectric effect. If the intensity of the incident beam does not change, which of the following graphs best represents the variation of number of electrons emitted per second? Remember, intensity, number of electrons emitted per second. Intensity is proportional to number of electrons emitted. Number of electrons emitted. Now, what is this photoelectric effect? This is what you mean by photoelectric effect. Very simple. There is a metal surface. Electromagnetic waves coming. This will strike the metal, causing electrons to emit. There. Now they have found out number of photons hitting the metal surface is proportional to number of electrons emitted. But remember this very carefully. It doesn't happen for all frequencies. If the incident frequency is greater than something called the threshold frequency. Threshold frequency only, photoelectrons are emitted. Photoelectrons are emitted. Otherwise, no emission takes place. So you must know intensity. I is intensity. Yeah? Write inside brackets. Intensity of light. Intensity of light. directly proportional to number of electrons emitted. Right? Number of electrons emitted. Right. Now look at this carefully. If the intensity is constant, they are telling intensity is constant. If the intensity is constant, not change. Intensity is constant means number of electrons emitted will also be constant after the threshold frequency. F naught represents threshold frequency. So after the threshold frequency, intensity is constant. So number of electrons emitted will also be constant. This is correct. This is correct. All these are wrong. Why? You have 2 now. Before the threshold, no photoelectrons are emitted. These also wrong. Only correct answer is answer number 4. Only correct answer is answer number 4. Right? Let's write now. Since the intensity is constant, photoelectrons emitted will also be constant. Photoelectrons emitted will also be constant. Okay? Photoelectrons emitted will also be constant. Okay. Right. Okay. Next is a potentiometer problem. Now in a potentiometer theory, potentiometer is potential difference. Delta V will stand for potential difference. Potential difference is directly proportional to the balance net. That's all. Potential difference is directly proportional to the balance net. Now read the question, Milu. Read the question. In the potentiometer circuit shown, internal resistance of cell E is negligible. No internal resistance. No internal resistance. I'll highlight this with blue. Right. The balance length L is obtained for cell E naught. Now, when the balance length occurs, current is 0. Current through the galvanometer is going to be 0. So remember this, at the balance point, there is no current passing through the galvanometer. Right. So no current means even if you apply Kirchhoff law here, if I name this A, if I name this C, let that be B will. If you apply Kirchhoff law there, sum of EMFs equals sum of potential differences minus to plus positive, that is equal to potential difference across AC. Remember, there is no current going here. The only current is coming from the primary circuit. Primary circuit, let's say I'll name this IP. Primary circuit will keep, IP current will keep going. This is your primary circuit. Primary circuit. This is your secondary circuit. Secondary circuit. So you have experience. Primary circuit current IP into resistance RAC. What is resistance? Yesterday I taught rho L over A. L over A. IP current rho A constant. So E naught is equal to IP rho A L. IP is the primary current. Primary current. Primary current. Right. What are they telling you? The balance length L is obtained for the cell E naught is doubled when a resistance R is connected in series with E. I'll draw the circuit. I'm connecting a resistance R in series with E. Balance length has doubled its sim when I connect E naught. Balance length has doubled. Think carefully and answer this. How can the balance length double? How can this double? Will rho change? No. Will A change? No. This has doubled because the primary current has become same E naught. No. If I apply Kirchhoff law here, If I apply Kirchhoff law here, again no current. Only primary current is coming, but different primary current, IP dash. IP dash. But now you have idea. If you apply Kirchhoff law here, sum of EMFs equals sum of potential differences. E naught is equal to is A C dash. IP dash RAC. What is IP dash? Rho 2L over A. These two are equal. Rho LA IP. These two are equal. Rho LA. 2 times IP is equal to IP. 2 times IP dash equals IP. So if I take equation 1, if I take equation 2, think 1 and 2 are equal. Here itself I told you. How can the length double? Length is double because the current is half. Let's see. IP is equal to 2 times IP dash. Right now, IP dash equals IP divided by 2. No need to do everything. Here length has double means current has become half. How can the current has become half? Because the resistance has doubled. When the resistance doubles, the current will become what? Half. They are asking you, what is the resistance of the potentiometer? Think carefully. When I put a resistance here R, current has become half. That's because the resistance has doubled. Once I put R, resistance double means initially the resistance here was how much? R. R and R means 2R, double. So what's the resistance of the potentiometer? Resistance of the potentiometer is R. So if you are doing this in your head, look at this carefully. When I put in series, length as double means E naught has not changed. That has not changed. Length as double means current has become half. Current has become half means resistance has double. Resistance has double means resistance I put is equal to the resistance which was there in the beginning. Beginning, this is there. Resistance is R. Only that is there. So whatever I put as double, that means this resistance is also equal to R. Okay, no? So right there, point form, first one. When we put a resistor R in series, the length has doubled. When we put a resistor R in series, the length has doubled. The length has doubled means the current in the primary circuit has become half. The length has doubled means the current in the primary circuit has become half. The current in the primary circuit has become half. Current in the primary circuit is half means resistance has doubled. Resistance has doubled. This means the potentiometer wire has a resistance R. This means the potentiometer wire has a resistance R. So no need to do all these calculations, but I showed you how to get it. Length has doubled because rho and A won't change. E naught has not changed. Current has become half. Current is half means resistance is double. Once I put this resistance double means this also R. Okay, now? The correct answer is answer number 2. Correct answer is answer number 2. Right. 3 identical cells EMF E negligible internal resistance. Potential drop across AB. AB potential difference they are asking. Right. So I think you can apply A to B, no? A, B, no? A to B, you can apply the loop. A to B. Sum of EMF equal sum of potential differences. A to B means VAB, potential difference. Loop is going from minus to plus, positive. Loop is going from minus to plus, positive. VAB is equal to positive 2E. Positive 2E means answer number 4. Directly applying Kirchhoff, you can get the answer. Directly applying Kirchhoff, you can get the answer for the open terminals. Okay, no? For the open terminals. Right. Final question MCQ. voltage divider. Voltage divider. Now remember, these are terminals which are connected to a battery. V naught is given, they are connected to a battery. These two here, they are open terminals. We are supposed to find the potential difference there. These are open terminals. Now, when you need to find the potential difference across this, these two resistors are parallel to each other. Parallel resistors have same voltage, right? So if I draw this resistor R, here also resistor R, parallel resistors, how do you find the equivalent? Now when we are doing capacitors also I told this. Parallel means multiply both, divide by the addition. Multiply both, divide by the addition. Or O-level way, parallel means 1 over R equivalent. You will apply this and get the answer. A-level, we don't have time for all of that. If you want to do this, it's okay. 2 divided by 2R. What is R equivalent? R, no, R equivalent dash. I'll of course multiply both 2R, 4R squared divided by the addition. 2R, 4R. 4R squared divided by 4R is going to be R. So here you have a resistance R. So the voltage here and the voltage across the equivalent will be same. Across this or across this whole equivalent, voltage is same, parallel. What can you say about these two? These two are also what? Parallel. Parallel means here R. How do you get the equivalent? R and R. Oh, I'm sorry. I forgot to put one part, no? I forgot to put one part. Right, sorry. So here there is another pathway. Resistance R, this here. 2R will be R here, right? What can you say about these two? Are they in series or parallel? These open terminals. Across the open terminals, current can't go. Current will go across them like this. So these two are in series. Series means 2R. Series means 2R. Now 2R and R are parallel. 2R and R are parallel. How do you get the equivalent? Very simple. Multiply both. 2R squared divide by addition 3R. So 2R divided by 3 R here. Right. Look at the board now. Huh? Here V naught. Here V naught. Here V naught. This voltage only we need. Right. Potential divider. Let's find the voltage here. Let's find the voltage there. This voltage. I'll name this V1. See the shortcut to find the potential difference. Multiply the resistor by the total voltage. 2R divided by 3 times V0 divided by the addition. Addition means R plus 2R over 3. R plus 2R over 3. One I will write. R plus 2R over 3. Here you will get 5R over 3. 2V0 divided by 5. V1 I have found. This terminal, V1. That means that terminal, V1. V1. This is V1. Again, this terminal, V1. Here you go, V1 here. How do you find this voltage? Just like the early one. How do you find this? Resistor into total voltage in the branch. Resistor into total voltage. R times V1. V1 is 2V0 divided by 5. Divide by the addition. Divide by the addition is 2R. RR cancel off, 2 cancel off. V naught divided by 5. V is equal to V naught divided by 5. So V over V naught is 1 over 5. Answer number 4. Answer number 4. So here, this voltage, this is V, this is also V. This voltage is V1. So what I did was you make the resistor circuit smaller to one branch. V1 I found. Once I know V1, here also V1, here also V1, here also V1. Voltage across this and voltage across there both are same. So I get one resistor. How do I find this? V R times total voltage in that branch divided by the addition. From there you can get your answer 1 over 5. Short methods to get the answer. Okay. Right. Okay. Right. Structured essay. Right. Figure shows an apparatus arranged by a student to generate steam. This is a practical to find the latent heat of vaporization. Right. In this setup, the two tubes A and B are fixed incorrectly. They are telling you it is fixed incorrectly. State how you would arrange them properly. Remember, this A here, now from here only steam is carried. You can't have it inside water. This should stop from here. This should start from here. And this should go underwater. Right? This tube is to regulate pressure. When the steam increases, actual inside steam pressure will increase. So if I draw this foil, tube A should go underwater, tube B should be outside like this. So B will take steam. When the pressure inside increases, this is nicely closed now. When the pressure inside increases, pressure will push the water down, water will rise along the tube and regulate the pressure. Otherwise, it will explode. So A should be inserted inside, B should be outside water. A should be inserted inside water or into water. B is out of water. Right. What is the purpose of having tube A? Why do you have tube A? Tube A is to regulate the excess pressure. Regulate the excess pressure. So you can say regulate the excess pressure buildup. Inside the steam generator. Regulate the excess pressure buildup inside the steam generator. Okay, now? Right. So regulate the excess pressure buildup inside the steam generator. And for safety also you can put. Now when it's inside, this excess pressure buildup will be stopped. Yeah. Excess pressure buildup will be stopped. Right. Next one. After making the changes mentioned in part A, the student decided to use the above setup to determine the specific latent heat of vaporization by inserting the outlet of the tube directly into the calorimeter C. That means what is happening? That means we are inserting this directly into the calorimeter. Inserting direct to the calorimeter. Wrong. If you insert directly into the calorimeter, there will be a mixture of water and steam. When steam touches the water, condensation will take place. We want pure steam to go, not a mixture of water and steam. Right there. Right there. There will be a mixture of water and steam. Water and steam added to the calorimeter. Added to the calorimeter. This is not suitable. This is not suitable. Right. Correct procedure in this experiment would be to connect another piece of apparatus to the outlet of tube B before passing it into the meter. Draw this piece between the space given. Right. Let's draw this. So how will you draw this? So here you go. The tube should be just above the water surface. Not inside water, just above. Just above. This black line is the water surface. So I will keep the water line here, just above the water surface. Okay. Right. So what is happening here? Condensed steam will collect here as water. Pure steam only will go. Pure steam will go and spread along the surface. Spread along the surface. Right. Spread along the surface. So you call this the steam condenser. Steam condenser. Steam condenser. Okay, no? Right. In addition to temperature measurements, what are the other measurements that you would take? In addition to the two relevant temperature measurements, what are the additional measurements that you will take? What are the additional measurements that you will take? Right. Let's write. Mass of empty calorimeter and stirrer. Mass of empty calorimeter and stirrer. There you go. Mass of calorimeter, stirrer and water. That's the order. Mass of calorimeter, stirrer and water. M2. Initial temperature of water. Initial temperature of water. We start 5 degrees below room temperature. Send in steam. Final maximum temperature. The word maximum must come. Maximum temperature of water. Theta 2. Final maximum temperature of water. Allow the system to cool down. Mass of the calorimeter and all its contents. All its contents. There you go, M3. There you go, M3. Final mass of calorimeter was at. Right. So there you go. Don't write these two because they are given you, but I wrote the whole setup. They'll give you marks for this. They'll give you marks for this. Sorry. They'll give you marks for this. One, sorry, not for that. Right. For this, they'll give you marks. This one, this one, this one, this one. These two are anyway given in the question. Right. Point number 1, point number 2, point number 3. Right. Now, I think this one mistakenly is printed there because part of the question is missing. You can see. Don't worry, that question I added later. Yeah. So this is, you can ignore part of the question. The question continues from here. Huh? The earlier question continues from here. Right. From here. We are still in specific latent heat of vaporization. Right. What additional data will you compute for the specific latent heat of vaporization? You will need specific heat capacity of calorimeter. Then you will need specific heat capacity of water. You will need specific heat capacity of calorimeter, specific heat capacity of water. Right. Specific heat capacity of water. Right. What precautions would you take in order to improve the accuracy of the experiment? Now, remember, first thing you must write is, you must allow to minimize the heat loss to the environment. How do you minimize the heat loss to the environment? We start the experiment. 5 degrees below room temperature. Below room temperature. Remember, dew must not form. Huh? Dew must not form. And we send steam. And we send steam until it is 5 degrees above room temperature. Why is this? Why are we starting 5 degrees below and finishing 5 degrees above? Simple. Room temperature is there. If you are starting below, from the room, heat will come in. If you finish above, from the heat, from the room, heat will come in. If it's above, from the vessel, heat will go out. Heat coming in, heat going out will cancel off. So heat loss to the environment can be removed. Understood? So you are starting the experiment 5 degrees below room temperature, dew must not form, huh? Above dew point. And we send in steam until it is 5 degrees above room temperature. So that heat loss to the surroundings can be ignored. Can be ignored. Okay. That is one. What's the next one? What's the next one? Remember, we must make sure there is no heat loss when you mix the steam. So when you mix it, quickly close the calorimeter lid and stir continuously. Yeah. Quickly close the calorimeter. Quickly close the calorimeter and continuously stir. Continuously stir. Right. What else? If you look at this, there is a very important thing happening here. Here, if you see, there is a be a Bunsen burner. From this heat can come. Heat can come as radiation. What we must do is put a white screen or as white screen or asbestos sheet to stop radiation heat transfer. To stop radiation heat transfer. That also you can write. That also you can write here. Right now, that also you can write here. You can say insert white screen. Why white screen? White screen is a good reflector of radiation. White screen or asbestos sheet. Not asbestos. I'm also writing it wrong. Asbestos. Asbestos. Asbestos sheet. Huh? Asbestos sheet to stop radiation heat transfer. Radiation heat transfer. Right. Sometimes spellings might go wrong, huh? Because from morning 7:30 teaching, so therefore sometimes spellings and all might go a bit wrong. Right. Anyway, the idea is there. Don't worry. The idea is there. Right. When the above experiment was carried out in a hill country school, hill country meaning atmospheric pressure will change. Don't worry. Atmospheric pressure changes means boiling point will change. When you go to the hill country, tell me, atmospheric pressure will increase or reduce? Increase or reduce? Tell me. Increase or reduce? Reduce. When it's reducing, boiling point temperature will also reduce. Right there, as we travel to a hill country, atmospheric pressure will reduce. Atmospheric pressure will reduce. Atmospheric pressure will reduce. Therefore, boiling point temperature will reduce. Therefore, boiling point temperature reduces. Right. Barometer reading was found to be 720 millimeter mercury. Explain how the student should take this factor into account. Atmospheric pressure has reduced. Atmospheric pressure has reduced. Therefore, boiling point temperature has reduced. Boiling point temperature has reduced. So we must consider now no more the boiling point is 100 degrees. It's less than that. Okay, no? Right. Okay. Moving on. Essay question. Nice. It is a eye defect question. Eye defect question. Right. Important, huh? Sketch two separate ray diagrams, one for the defective eye and the other for the normal eye, to illustrate when the image is at a distance of 25 centimeter is focused by the eye lens. Read the question again. The near point of a far-sighted person. That means this person can see infinity but cannot see 25 centimeters. Right. So here I'm drawing healthy eye. Healthy eye. Here I'm drawing defective eye. Defective eye. Right. Here we can draw the ray diagrams. Light rays are coming from 25 centimeters. Light rays come from 25 centimeters, will converge on the retina. Healthy eye. Defective eye, far-sighted, long-sighted. Light rays will converge behind the retina. This is the problem. Long-sighted people, light rays are converging behind. Long, short, long. converging long, far away. Okay. So at 25 centimeter, healthy eye on the retina, defective eye behind the retina. Okay, no? Right. Okay. Done, no? Just have a look at this and go with. Near point is 100. Okay, near point is 100. Right. We'll move this. Okay. What is the focal length and type of lens for the eyeglass that he should wear to correct his near point to 25 centimeter? Far-sighted people wear convex lenses. State the sign convention you use. Cartesian sign convention. All measurements are taken. Remember, essay question means guaranteed write the sign convention. If you don't write the sign convention, they will not give you some allocated marks. Whenever you do a optics question, guaranteed write the sign convention. Okay. All measurements are taken from the optical center. From optical center. Right. In the direction light travels, all measurements are negative. In the direction light travels. In the direction light travels. All measurements are negative. All measurements are negative. All measurements are negative. Next one. Opposite to the direction light travels, all measurements are positive. Opposite to the direction light travels. Opposite to the direction light travels. All measurements are positive. All measurements are positive. All measurements are positive. What else? All measurements above the principal axis. Above the principal axis. Positive. All measurements below the principal axis. Negative. All measurements. All measurements below the principal axis. Below principal axis. Negative. I hope you learned all these. Without this, you won't get full marks. All your principles should be written. Now let me go back. Let me go back and solve the problem. How do you correct the vision? Right. What I'll do is I'll go to the writing board. We didn't use the writing board for a long time. Right. Now, in the writing board, problem is I can't see at 25. Where can I see? I can see at 100. So remember, two lenses. Image from the first lens will act as the object for the second. So this is 25 centimeter. Light rays will go and form the image where the eye can see. Image from the lens is object for the eye. That is 100 centimeters. So you can apply here. If I draw ray diagrams, light rays will seem like to meet here. Light rays will seem like to meet there. That will converge on the retina. So if you write equations here, 1 over V minus 1 over U equals 1 over F for the glass lens. Object is kept at 25, image is formed at 100. Opposite, light is going this way. Opposite is positive. Everything U is positive, V is positive. Focal length of glass lens. Common denominator 100. 1 minus 4. Focal length of glass lens. Focal length 100 over 3. minus 33.3 centimeter convex. Convex. This is how you correct your vision. This is how you correct your vision. Right. Once you need it, write it down. Once you need it, write it down. Right. Okay. Considering that the lens of the eyeglass and the eye lens are in contact, that means combined lenses, calculate the focal length of the eye lens when an object is at a distance 25 centimeter, distance to the retina is 2.5. Right. Now look. Here now, object is at 25 centimeter, image is formed on the retina. Image is formed on the retina. That is 2.5 centimeters. So we know focal length here is minus 100 over 3 centimeters. What are they asking you? Focal length of the eye lens. Object is here, image is there. So I can apply 1 over V minus 1 over U equals 1 over F. 1 over F. U is 25 positive. V is minus 2.5. Equivalent focal length, I don't know. 1 over equivalent focal length, that is equal to minus 10 over 25 minus 1 over 25 minus 11 over 25. Also, you know 1 over F equivalent is 1 over F1 plus 1 over F2. In other words, focal length of glass plus focal length of eye. Here minus 11 over 25. Focal length of glass is 1 over 100 over 3. Focal length of eye. Minus 11 over 25. Minus 3 over 100 plus 3 over 100. Focal length of eye. Common denominator is 100. So 44 plus 3. Focal length of eye. Focal length of eye is minus 100 divided by 41. If you divide this, first the answer you will get minus 100 divided by 41 is how much? Minus 2.4 centimeter. For 82 you have 2, 180. 180 means 41 times 4, 164. So minus 2.4 centimeter focal length of the eye. So I'm taking this as the object distance. Light is going that way. All optical center, opposite is positive, in the direction minus. There you go. Okay. Right. When the object is at infinity, is focused on the retina by the eye without the eyeglass, without the spectacles, he can see it. What's the power? So light rays come from infinity. Light rays coming from infinity will converge on the retina 2.5. So what's the focal length? Converging convex lens means focal length is same. Right. The focal length of the eye is minus 2.5 centimeters. Power is equal to minus 1 over F minus 2.5. Please substitute in meters. minus minus plus 100 divided by 2.5, because you must put this in meters. Meters only will make this what? Diopters. 1000 divided by 25 will give you 40 diopter. So right now, common sense, light rays coming from infinity will converge, means these are convex lens. Convex lens means that's your focal. Once you know that is the focal, substitute there. Minus 1 over f. F is minus 2.5, don't put centimeter, meter. 2.5 divided by 100. Minus minus plus 100 divided by 2.5, jump a decimal. 1000 divided by 25, 40. 40 diopter. 40 diopter. Okay. Right. Okay. Done. Okay then. That concludes the work for today. Hopefully it was productive. You all did it. You all did the correction. Now tomorrow's work, please do it. Be ready. I'll meet you at the same time. Usual time is 9 o'clock. So we'll meet exactly at 9. Huh? Normally now 2 days we have done it. All 2 days by 11 o'clock it's over. So 9 to 11, keep it free. Okay then. Stay home safe. See you tomorrow. Good night.